Welcome to today's math lesson. If you will make your way to Schoology to your math course, there is a folder that has been added for this week, the 20th through the 24th. If you will open that and go to today's folder, you will see today's assignment. You are going to open it with Kami. It will probably prompt you to log in with Google if you will do that. Okay, we are ready to get started. We will be working with two standards today, between today and tomorrow. We are still talking about numerical expressions. Now we're going to add in those whole number exponents. And then we're still want to be able to use variables to represent numbers and write expressions when solving real world or mathematical problems. So there are two start problems here, or bell ringers, however you would like to phrase them. And if you want to time yourself for about 4 or 5 minutes to complete these, hit pause, complete these two problems, and then continue the video to find the answers. So for this particular problem here, number 1, we are finding the area of this wooden block. And anytime we have a shape that is not a square, rectangle, parallelogram, or a triangle, we then have to divide it into those shapes. So we decompose first. So when I decompose this shape, I can section off those two portions. And now I have 3 shapes. I have 2 small squares and then a rectangle. So this square is a 2 by 2. This one also happens to be a 2 by 2. If we are finding the area of a square, then we would do length times width. So we would do 2 times 2, which would be 4. So each one of these squares is 4 inches squared. Then I would look at my longer rectangle here. This side from the square would have been 2. Then we have 4. 2 plus 4 is 6, plus another 2 more. That would be 8. So we have 8 inches, or you could have looked across the bottom here, 8 inches. And then the entire length here is 4. From the bottom to the top here is 4. But we know that this square had that measure of 2, so that leaves us with 2 here. So we have length times width for the area of a rectangle. So we would be talking about 2 times 8. 2 times 8 would be 16. So then I add all of those areas together. I would add 4 plus 4 plus 16. So this would be 14. 4, carry my 1, 24 inches squared. That is the total area there. So again, you decompose and then find the areas of each and add each area together. Number 2 was another most missed question on our common assessment that we took a little while back. It's a trapezoid, and you have to find the area of it. Many people just multiplied base times height, and we don't have an area formula for a trapezoid. So in this case, you had to decompose it. So you had to decompose and break off the triangular pieces on the side. So we know that from here to here, we have 5, and we know that this length here is 4. That is a rectangle, so we would do 5 times 4 for length times width, and that would equal 20. So this one is 20. And then your 2 triangular pieces, to get your bottom base, we know that the middle portion here was 5. So then we say 9 minus 5 would be 4. So this space is 2 and this space is 2 because those triangles are identical to each other. Now, area formula for a triangle is 1/2 of your base times your height. So we have a base of 2 and a height of 4. We multiply that together to get 8. Half of 8 would be 4. So each triangle has an area of 4. So I've decomposed. I found the area of each piece, and now I need to add the area of each. So we have 20 plus 4 plus 4, which would give us 28 yards squared. Remember, when working with area, we are talking about square units. So that gives us our answers to our START problems. At the end of this lesson, if you're working from home, you can always work on your 5 ALEKS topics for the week. Remember, I will be checking those and putting those in Skyward if you completed. Next, we have a try-it problem. In this try-it problem, it says David builds a house for his cat using cubes with edges that are 1 foot long. He builds the house by making 4 layers of cubes. Each layer is made up of 4 rows and 4 columns. How many cubes does David use for the house? Now, we are going to start talking about exponents. So remember that if you ever have something such as 4 times 4 times 4, then we can write that as 4 cubed. Or if we had 6 times 6, that would be 6 squared. So that is how exponents work. It is repeated multiplication shown with this little exponent here. So the base number is the number that is being repeated. The exponent is how many times you are multiplying that number by itself. So I want you to pause the video and attempt this problem on your own. Remember, he is building a cat house, and this cat house has 4 layers. And then inside each layer, there's 1, 2, 3, 4 layers. Yep. Inside each layer, there are 4 rows. I'll have to add here. That gives me 4. 1, 2, 3, 4. Yeah. And 4 columns. And that is in each layer. So you are going to figure out how many cubes he's going to use. Remember to pause the video and try this on your own. So now that you've had some time to try to solve this on your own, let's take a look at it together. We can see that if we have 4 rows and 4 columns, that's the same thing as a 4 times 4, right? So we have, if we were writing this as exponents, we could write this as 4 squared. And each layer is 4 squared. If we know what 4 squared is, we know that 4 times 4 is 16. So we will have 16 in 4 layers. So 16 times 4. So this would be 24. 4, carry your 2 over. 4 times 1 is 4 plus 2 more is 6. So 64 cubes in this cat house. Let's take a look at some more problems. So that was a real world try-it problem. We're going to look at some apply-it problems now. So number 7 here says, which expression is equivalent to 7 times 7 times 7 times 3 times 3? Now remember, when we write exponents, we do the base. So this has 2 different base numbers. We have 7 being repeated, and then we also have 3 being repeated. So then we look at how many times did 7 get repeated? Well, 1, 2, 3 times. Times, how many times did 3 get repeated? Well, it got repeated 2 times. So then we just look for an answer choice that matches this. which would be C in this case. And at any point, if you would like to try these on your own and then come back and check your answers, please remember to do that. So now we're on number 8. It says evaluate n to the third when n equals 2/3. Show your work. So this is one of those where they're giving us a value to replace our variable. Remember, variables are the letters, the unknowns in an expression. So our expression is n to the third, and we want to replace n with 2/3. So this is 2/3 cubed. So this would be 2/3 times 2/3 times 2/3. And when we do that, when we're multiplying fractions, we multiply across the top, and then we multiply across the bottom. So 2 times 2 times 2, so 2 times 2 is 4, times 2 more would be 8, and then 3 times 3 is 9, times 3 would be 27. So we have 8/27. Let's take a look at the next one here. This is a discuss it one where we would compare class strategies if you were in person with me today. So if you want to try this one and then talk to someone at home about it, and then if you need to come back after that and check out your answer, then please do so. So number 9 on the Lucky 5 game show, Troy wins, it should say $5 for each question he answers when he answers one question correctly. Each time he answers another question correctly without making a mistake, the amount of money he wins is multiplied by 5. Troy answers 6 questions correctly without making a mistake. So this is saying that he earned $5 for the first question and then 5 for every other question. And it says that he answered 6 questions correctly. So his winnings are represented as 5 to the 6th power. So we know the expression is this, and it wants to know how much money does Troy win. So we are going to figure out what 5 to the 6 equals. So what you need to do is you need to do 5 times 5 times 5 times 5. That's 1, 2, 3, 4 times 5 times 5. Now, do not say 5 times 6 because the 5 is repeated 6 times. Multiplication can represent repeated addition. So if you had 5 plus 5 plus 5 plus 5 plus 5 plus 5, then we could say 5 times 6. But we can't do that when we're repeatedly multiplying. So you're actually going to have to multiply this out. So take a minute and do that, and then come back to the video. So with this particular question, I had put a calculator link here on the Try It problem. And when you click that link, it takes you to a Desmos graphing calculator. And I'm going to have to move this little guy out of the way if I can. Okay, so this Desmos graphing calculator has some different options. Oh, here we go. This is what I was looking for. There it is. Okay. So this gives you some options where you can work with exponents and actually calculate them. So if we type in 5 with our calculator here and we're using an exponent, this is 5 to the 6th power, and then we hit equal, it will, you don't have to hit equal. It just tells you it equals 15,625. So that is what you should have gotten for your answer here. And I don't mind you checking answers with the Desmos calculator. Just make sure that you're not just copying answers straight from there. So with this, our answer for this question was $15,625. That is how much he would have won by answering 6 questions in a row correctly without any mistakes. This next group of apply problems, I would like for you to try on your own before you follow along with me, just to get some practice in, and then come back and watch the video. So number 8 says Tamara is using rice paper to make Japanese lanterns. The expression 2s squared plus 40s represents the surface area of a lantern where the base edges are s inches long. So that is pictured over here to the side. We have s and s on the bottom, and then we have our height of 10. It says, what is the surface area of the lantern when S is 9? So they give us the expression. We just have to plug in 9 where we see S. So 2s squared plus 40s. Now remember, when we have a number next to a variable like this, then we are multiplying. So we can go ahead and put parentheses. So 2 times 9 squared plus 40 times 9. So you would solve this. You would then say, okay, I need to follow my order of operations, GEMS. There are no groupings. There are exponents. There's one exponent, so I have to do that first. I have to do 9 squared. Well, 9 squared would be 9 times 9. 9 times 9, if we're doing that, then that is 81. So then I have 2 times 81 plus 40 times 9. So then I would do my multiplication. So I would multiply here, and I would also multiply here. And then I would do my addition and subtraction. In this case, it would just be adding what I get when I multiply those two. So that will give you your solution for the surface area of that lantern. Let's take a look at number 9. What is the value of the expression 5 times 3 cubed minus 4? So we're just following order of operations with this expression. They give us an expression, follow order of operations. So GEMS. So we do the exponent first. 3 times 3 would be 9 times 3, because we have to multiply 3 times, right? Which would be 27. So 27 minus 4, and then of course we have to remember to bring our 5. 27 minus 4 would be 23 times 5. So you're going to multiply here and then get your final answer, your solution, after you have found the value of that expression. That brings us to our exit ticket for today. I would really like for you to do this one on your own. I will say that, remember, the expression is given to you. Okay, so what is the value of m plus 4n squared minus 5q plus 4 when m equals 5, n equals 2, and q equals 3? So you're plugging in. I will go ahead and do this part for you. So m plus 4n squared plus 5q plus 4, right? So m is 5 plus 4. N is 2, so 2 squared plus 5 times 3 plus 4. So now you are just following GEMS to find your solution. No groupings, but you are going to start with your exponent. So there's a little bit of help with your exit ticket. Make sure that you answer it to the best of your abilities. Remember, at any point, if you're working from home and you have questions, please message me on Schoology or have your parents message me on Remind. We can always try to Zoom really quickly and get questions answered. So that would be your exit ticket. And then if you have some extra time and would like to take a look at two more try it problems for a little more challenge, you are welcome to do that, but they are not required problems. It's just if you have time and you get done with your work. Also remember that you have ALEKS and that you can work on your ALEKS topics. And then if you need something more for math, there are math stations in Schoology as well.